Let's start chapter 9.2 and 9.3. I kind of treat it all as one big unit. It's a whole new way of looking at motion and curves. The first thing we need to talk about is a little bit of housekeeping. Chapter 9 is not in the volume of Apex Calculus that we've been using so far, which is Calc 2. It's in their Calc 3 volume. Fortunately, it's a free download anyway, so if you go to apexcalculus.com/downloads, let's do that here, and scroll down. We want Apex Calculus 3, which includes Chapter 9, and we don't need the black and white, we don't need the color content, we don't need the 3D content, so just this black and white link is fine, or there's a direct link to it that I'll put in the video description here. So a good first question might be, why should we care about parametrics? There's lots of interesting things going on with parametrics. You can talk about flow trajectories, like here's a graph of blood flow in the heart, where they've got some little particles of blood colored in red because they leave the heart after one contraction, and then the yellow particles actually stay and just kind of swirl around in the chamber and maybe get ejected on the next contraction. You can talk about, so the individual curves here we can describe with parametric functions or parametric data. In computers, keeping computers cool, there's flow trajectories you can do, and you can use parametric curves to describe the flow of little pockets of air as they move along there. Back to biology for a sec, people have attached satellite transponders to animals like elephant seals here, and here's the Washington, Oregon, California, Mexico coast, and this is where 4 different elephant seals went. We can say, like, here's seal number 541, here's seal number 546, and we can also ask what speed was that animal going as the days go by. So speed of a parametric curve or function is something we're going to be talking about as well. Another thing, I was reading about front-wheel drive versus rear-wheel drive a while ago for cars, and someone said, why are front-wheel drives more common now than they were 40 years ago or whatever? And one of the answers was that the constant velocity joint you need to do front-wheel drive well, that depends on precise grinding that comes from parametrics, and the machines just weren't good at it 20 years or 40 years ago. So all kinds of interesting reasons to study parametrics. I have to admit this one is more of a Calc 3 kind of parametric thing than Calc 2, but that's all related. So here's an outline of what we're going to do in Chapter 2.3 and 9.2 and 9.3. So we'll do an intro based on a data set in the next video. Then we'll talk about graphing in Excel and Desmos. We'll talk about some fun toys called spirographs. We'll do some basic straight line motions, and we'll do some curves, and talk about velocity, speed, and acceleration, and some arc length stuff.